see it, I see it.
We do!
The cave is collapsing.
There's no cave.
What?
Simplifying the space slug. The space slug has a similar shape to a cylinder with a conical frustum on top. If the space slug had its mouth fully opened, it would have a shape that is approximately a cylinder. Some additional information is that the body length is 800 meters, the max width is 80 meters, the mouth length is 40 meters, and the rate that the mouth is closing at is around 1.6 meters per second. The rate of change of the volume of the space slug. Because the volume of the cylinder is constant, the related rate is associated with the volume of the conical frustum. What is the rate of change of the volume of the space slug when the mouth is at the dimension, the top radius is equal to 17 meters? The equation for the volume of a conical frustum, when referenced from on a side, is the volume is equal to the radius of the base squared plus the radius of the top squared plus the radius of the base times the radius of the top, all of that multiplied by 1/3 times pi times the length. The equation of the rate of change of the volume of the space slug. I find the equation to be the following, which can be simplified because the radius of the base and the length are constant, so the derivatives with respect to time are equal to 0, and the equation is simplified to the derivative of volume with respect to time is equal to 1/3 times pi times the length, all of that times the rate of change of the top with respect to time times 2 times the radius of the top plus the radius of the base. When I plug in the numbers given in slide 3, I find the rate of change to be negative 4,959.78 meters cubed per second. And from that, I can say at the instant that the mouth has a radius 17 meters, the rate of change of the volume of the space slug is around negative 5,000 meters cubed per second.
The next thing we want to determine is how fast the Millennium Falcon was moving. After narrowly escaping the worm's mouth, the Millennium Falcon continues to fly away from the worm at an upward angle. We want to know the Falcon's speed after it was in 25 feet away from the worm. Furthermore, we will find this rate under the knowledge the Falcon changes its y or vertical direction at 5 feet per second. Facts about the Falcon. The Falcon has a constant length of 114 feet. Additionally, we are going to assume that our y value is 25 feet and our derivative of y in relation to t is 5 feet per second. Setting up our problem. To determine the speed at which the Falcon is moving, we need to use Pythagorean's theorem and relate the Falcon's height and length to its distance. However, to solve for the rate of the distance, the formula will require the length of x at this time. To solve for this, one must use Pythagorean theorems without taking the implicit derivative to find the distance at the given point. So, our two theorems, Pythagorean theorem in and of itself, c squared equals y squared times x squared, and once we've taken the implicit derivative, 2c times the derivative of c in relation to t equals y squared times 2x times the derivative of x in relation to t plus x squared times 2y, the derivative of y in relation to t. Note that the implicit formula was given using product rule on the original formula. Now that we know the basic formulas we use, we simply plug in what we have learned and then we use it to find our derivative of x in relation to t. So, we cannot find the derivative of x in relation to t until we know x. We established this earlier. So we use the Pythagorean theorem that we said earlier to solve for x. Given that c is 114, because that is our length, and the length of the Falcon, and 25 is y, because that's what we said, we can solve that x is 111.225. So we take this formula and we put it into the implicit formula we worked in the first slide. Putting that number in addition to the constants of that we know c is 114, y is 25, and the derivative of y in relation to t, or the rate y changes, is 5. Using all of these formulas and plugging it into our equation, we get that 0, because our length remains constant, equals 13903.25 times the derivative of x in relation to t plus 309,344.5.313. When you solve for the derivative of x in relation to t, you get 22.25. This means that the falcon speed in the x or horizontal direction is 22.25 feet per second away from the worm.